So let's just dive right into it. Okay, the first slide says, a quilt for a twin bed is 68 inches by 90 inches. What's the area of the backing applied to the quilt? Right, so on your homework tonight, I'm going to have you do this. Figure out. I'm going to ask you the question, are you trying to find perimeter, area, or circumference? Well, with this problem, what are we trying to do? Really? Area, because it does specifically say, what is the area? Well, that makes it easy when it puts it just like that, okay? What shape is a quilt? What shape would it be? Krista? A rectangle, right? If you took your bedding off your bed and laid it on the floor, it's just a big rectangle, okay? So we have this rectangle that is 68 inches by 90 inches, and we're trying to find the area. Okay, now, if we need to, we go back to our formula sheet. What formula am I going to use to find the area of that rectangle? What are we going to do? Tyler? Area equals base times height. So in this case, that's 90 times 68. What do you get? Brinley, go ahead. 6,120, and it would be inches squared because it's area. Okay? Then it says, the second part, a ruffle is sewn to the edge of the quilt. How many feet of ruffle are needed to go all the way around the edge of the quilt? Where does the ruffle go on a quilt? Is it the perimeter, the area, or the circumference? If we're putting a ruffle around the edge, is that perimeter, area, or circumference? What do you think? Go ahead, Brandon. Perimeter, right? It's going around the edge. So we have this quilt that's 68 by 90, and we're going to put a ruffle along this edge, and this edge. So what am I going to do to figure out how much ruffle we need? Go ahead, Brandon. Add the sides together, right? So we have to do 68 plus 90. Is that it? No, that's only two of the sides. We need to cover all four sides. So plus 68 plus 90. So we add that all together, and you get 316 feet or inches? Which one? Inches, right? Okay, but the question says how many feet? So what do I do with that? I know it's 316 inches that I need. How am I going to figure out how many feet I need? How many inches are in a foot? Come on, guys. Shout it out. 12, right? 12 inches in a foot. So we're going to take 316 divided by 12, and you get 26.3 feet. Okay. So to have enough to make it all the way around the edge of the quilt, we need 26.3 feet. Questions there? Okay, let's look at the second one. Jackie is painting the walls in a room. 2 walls are 12 feet by 8 feet, and 2 walls are 10 feet by 8 feet. What is the area of the walls to be painted? Okay, so for the first part, are we finding perimeter, area, or circumference? Caleb?
Area.
Area. Some of them are easy, right? Because this does say, what is the area Okay, so it does specifically ask you area. What shape are walls? If I think about the walls in here, what shape are they? Are they circles? Are they triangles? Are they rectangles? Are they parallelograms? What are they? Hayden?
Rectangle.
Rectangles, right? So we're covering a rectangle with paint. And how many walls are we painting? Brooklyn? 4 of them. So I have 2 walls that are 12 feet by 8 feet. So I have that twice. And I have 2 walls that are 10 feet by 8 feet. Okay? You guys, I like to draw pictures of what I'm doing. It makes it way easier for me so that I can see what I need to find. So I need to find the area of this rectangle. How do I find the area of that rectangle? Caleb, base times height. 8 times 12. 8 times 12 is 96, right? 8 times, double check my math, yeah, 96. Okay, so that means this one is also 96. How about this one? What's this wall going to be? Really? 80, 8 times 10. What do we do with all those numbers? Krista? Add them all together. So 96 plus 96 plus 80 plus 80, it's 352 feet squared. Okay? Now, you have to buy enough paint. So you go to the paint store, right? You go to Menards or Home Depot, wherever you're going to buy your paint. And a can of paint covers 300 square feet. How many cans of paint should you buy? How are we going to figure out how many cans of paint we should buy? Is 1 can going to be enough? No, you're going to run out, right? So how many cans are you going to buy? Tyler? 2. Because 1 can covers 300, 2 cans would cover 600. I need 2 cans of paint. Is that too much paint? Yeah, but do I have a choice? No, not really. I can't tell them, oh, I really don't need that much. Can you dump about, most of it out and just give me a little bit? They'll look at me like I'm crazy. Okay, so is it good to have leftover paint?
Yeah.
Yes, why? Yeah, just in case you have kids running around your house that like scratch up your wall or color on your walls. Do you guys ever have little siblings that color on the walls? Some of you are nodding yes. Like, they take a color crayon and they just scribble over the whole wall. Then you need paint to cover it up. Or a marker.
Yeah, my brother.
That's your brother?
Downstairs, the walls are covered.
Yeah. That's, they had this brilliant idea of having chalk paint where then kids can write on the wall. I don't know, that was a good idea. And they just think that they can write on every wall. But whatever. Okay. The next one. A bicycle odometer. You guys know what an odometer is? There's odometers on cars, bicycles. What's an odometer? Okay, so let's finish reading it. Recorded 147 revolutions of a wheel. So what's an odometer? A tracker, kind of, yeah. So your odometer on your car keeps track of how many miles you drive. Okay, the little numbers on your car, okay, that tell you how many miles your vehicle has on it. Okay. Well, you can put those on a bicycle. You can. They're like a little sensor that just goes about right here, and then it senses how many times the wheel has gone around. So you can keep track of how far you bike. Okay? So the odometer recorded 147 revolutions. That means how many times it went around with a diameter of 1.3 feet. How far did the bicycle travel? Okay. If I'm recording revolutions, okay, let's say this was my bicycle wheel. Okay? And it's rolling along the ground. Do I want to find area or circumference? If I want to figure out how far it has traveled. What do I want to find? Do I want to find the area of the wheel? Or do I want to find the outside? Really? The circumference. Okay, when we're talking about how far it traveled, I want to find the circumference of the wheel. Okay, how do I find circumference? What's the formula for circumference? Brinley. C equals pi times diameter. Okay, so I fill in what I know. I know pi is 3.14. The diameter is what? Tyler? 1.3 feet. Okay, so we do that math. We do 3.14 times 1.3, and I got 4.1 feet. Am I done with this problem? No. Well, why not? So did my bike travel 4.1 feet? No. That's not very far. Okay. So now what do? Times it by 147. Okay, this distance right here is 1 revolution. This 4.1 is how far my bike traveled when the wheel turned 1 time. Okay, this time it says my bike went 147 revolutions. So I need to do 4.1 times 147, which is what? 602.7 feet. So the bike has traveled 602.7 feet. That sounds a little better. Okay? What? Okay, so good question. So Brooklyn said, why would you say miles? Well, because this was in feet, so I have to leave my label as feet. Okay? We could change it into miles. This isn't even a full mile yet. Do you guys know how many feet are in a mile? A lot. 5,280. Okay? There's 5,280 feet in a mile. So this isn't even close. This is like biking down your driveway or something. Okay, not some of your driveways, sorry. I forget. Some of us have really long driveways. Okay? All right, last problem. Flip the page. Okay, last one on the notes. A Ferris wheel has a diameter of 56 feet and makes 15 revolutions per ride. Okay? How far would someone travel during a ride? Use 3.14 for pi. Are we finding circumference or area? When you get on a Ferris wheel, okay, if you hop on the Ferris wheel on this yellow cart and it starts going around, goes around once, it goes around again, it goes around again, it goes around 15 times while you're riding. Are you finding area or circumference? Which one? Area would mean what? You're going over the middle, right? Circumference, right? You're going around the outside. You're not traveling in the middle of the Ferris wheel. When you get on the cart, it would be kind of fun. If you're, that'd be weird. If your Ferris wheel cart just went like all over the middle, I don't know how that would really work. Okay, you're traveling around the outside, which is the circumference. So C equals pi times diameter. Start with our formula. Okay, pi is 3.14. Do we know the diameter? Krista? 56. Okay, so we do our multiplying. 3.14 times 56. I got 175.8. Rounding to the nearest 10. Okay, so is that my final answer? No, what does that mean? The 175.8 means what? Caleb?
One revolution.
One time around. This is just one revolution. That'd be a really boring Ferris wheel ride if you just got to go one time around and be done. Oh, there you go, get off.
Yep.
Next, okay. This one actually goes 15 times around.
That's a lot.
That's a lot. That's a long Ferris wheel ride. That's maybe too long.
Yeah.
But what do I do with that 15? Tyler. So 175.8 times by 15. And I got 2,637 feet. So that is how far you would have traveled if you were just traveling along the ground. You're going in a circle the whole time. Okay? And you're not moving very fast, right? Ferris wheels are pretty slow, so it's not a real exciting ride.
Yeah. It's just for the
Okay.
ride.
Can you imagine if it was fast? The carts would be flinging upside down. Okay.
Yeah, we strapped on.
All right. So that's all the notes for today. That's it for notes for today.